Hi, and welcome to the next part of the series on learning p5js. And in here, we're going to start working on a little clicker game called PyramidClicker. So what I've done first is make a little bit of artwork in just a PSD file, and then I exported it as a PNG. Did the same thing with the with an awk icon. And so we've got those ready to go, and we go into our project. I've got it made, so this isn't going to be a series where we're going to make it together. I'm going to go through it and show how I did it, and it kind of gives you the idea of how it would work and how you could do the same sort of things yourself. All right? And that way we're not like bogged down in all of the trial and error of, oh, why isn't this working? Let's figure out the bugs. Because that is part of the process. But I'm just not going to show that here for the sake of time. And so we can see in the project that we have our sketch. I've just put it in a JS folder with a bunch of different other JS files. And in the HTML, we supported all those JS files here with script lines. We've got an image folder, and you can just upload a file to an image folder like this. Drag and drop your images in, and you can create folders up here with the create folder button if you need to. You have to do this before you make your files if you want to do that, because to put a file in a folder here, at least in the web browser version, you have to go under the folder and create a file in it. There's no like move files around for some reason, so keep that in mind. So the main sketch.js here is where everything's getting called from. And you'll notice that in addition to all these files, I've got a bunch of small functions, and that's basically we're breaking down all the code into small like Lego blocks and putting them in these categories over here so that we can find them and reuse them much easier. And so with any medium to large project, you're going to want to do that, because it's going to be like I could put all this code into this one sketch.js, but it would be humongous and really hard to find what you're looking for. So it's much easier to do this way. All right, so let's start at the top. Got init values. That's just going to set up our initial values that would be otherwise like just defined up here. And so we've got a function down below here because that's in our sketch, and it just calls different init values or init functions for each different type of thing. So doing it for time stuff, we're doing it for colors, the score, the onk icon, the workers, the zebu, which is a type of Egyptian cattle, and the favor. So if I play the game here, you can see we have our image loaded in. We have that kind of sand color continues down, so we're just filling the space with a flat color. And then we have, oh, I forgot to start this timer. If I don't have this timer, I will definitely go on for hours. All right, so the icon is here, right? And then we've got the score, which ticks up when we click this. You can see it bounces a little bit when we click it. And then once we reach a certain amount, these buttons start to show up on the left here for us to buy different stuff. We also have a rate, which is like how much score we're gaining per second. So if I do this really fast for a while, every 3 seconds or so, this will update and give us a value. And then if I have enough, this turns white and you can purchase a worker, or I can hold shift and buy multiple workers up to all the workers I can at least. And then buying a worker subtracts from the score, increases the worker price. It gives you a worker that's giving you a couple of things, giving you score every 3 seconds, 1 per. And it's also creating these little particles that show up. You get 1 for each worker. All right. And as you go higher and higher, you get the zebu and the favor. So I'm going to hack myself in some extra score here so we can show those. So you can see these are the 3 that we've got so far, and this is just a start for a project, so it doesn't have the full game yet. I could add more stuff in for sure. And then so we could buy a bunch of stuff. I could say, buy all those workers that you can get. And then we're getting 36 per second, or per 3 seconds, right? And then that gives us a pretty good amount to buy Zebu. And then once we've got a Zebu, we're getting 5 instead of 1 for one of these guys. That's how that works. So you can see one of those is a beefy guy, beefy Zebu cattle. And then if I restart it, I can buy the favor instead. And then, sure, we'll buy these as well. And then the favor gives you some glow when you start clicking. And the more it's glowing when you're clicking, or the more it's glowing, then the more score you will get every second while it's glowing. And then it'll slow down how much it's giving you. And you'll still yeah, that's pretty much how that works. So in the future, what I'd like to add is maybe some special events, like maybe get the Nile in here somewhere and have it flood, and then you get some prosperity. Start buying some stones, right? The quarries or something like that, and buying stone out of the quarry and being able to slowly build up your pyramid. I think that'd be really neat. And actually visually represent it being built in the background here. I think all that's pretty good ideas. There's all sorts of ideas with this sort of thing. So let's look at how it's working. We've got those init values, like I was saying. And then we're preloading the images so that we can use them later. This happens before setup, just one time. And then setup, we create the canvas at this static size, 800 by 600. We are defining a bunch of colors here. I'm not using all the colors, but there's quite a few nice little colors for me to use in here. And then back in the sketch, we have the buttons that we create. So each of these has a worker, Zebu, and a favor button, right? So those go in the respective files. So if we go to the worker one, there's a init worker. We're setting up the value that it shows up at. So when I got up to 5 from 0, the worker showed up. If you get up to 100 for Zebu, the button for Zebu shows up, and so on. So you can set values for that. And there's a cooldown. This is how long it takes between the workers doing some work. And then this is the timer that they use to tick up to that value. And then their initial price of 10. So you can see it goes up. And then the inflation is how much it's going up. So it's this 5% extra plus 1. And the initial number that you start with, and a list of particles. And then for the button, it's pretty simple. I just put create button, and then put the text in there. You see the short num seal here? This is actually a function that I made to shorten the numbers up to in the trillions. So once it gets beyond a certain point, it becomes 1.0k instead of 1000, and so on for millions, billions, trillions. And so I have one for ceilings and I have one for floors, because right now what I'm doing is flooring the score, the currency that I have, and putting ceiling for the prices. So if I see that this is 1.4k and this is 1.4k, I know that I can click that and it will actually purchase. Whereas if they're both floored, you could have slightly more favor and not be able to buy it, even though they say the same thing. So that's why we have these two. I think I was in worker button. Yeah. So this stuff is just positioning it, sizing it, setting the font size. So you have to use the style function for this stuff. It's just HTML basically, or CSS. And then sort of setting the color of the button to the worker color. We're just getting the RGB from it. And the border color is the highlight, so a little bit lighter. And then the text color starts out as black because we determined whether it should be black or white based on whether you can purchase it or not. And then the mouse pressed is the function that happens when you press the button. So when we press the button, we buy a worker down here. Yep, there it is. So buy worker says if you have enough score to pay for it, then check if they're pressing shift down. This key is down, and then the key code is 16 for shift. You can see that here if you're on this page. Or no, I think if you want to find the code for shift, there's a key code if you search for key code. And then in here, if you hit shift, there's this one right here. You can make this yourself, obviously, but I hit shift or I hit space 32. You get all the key codes for the letters and any other things. Control. So this is kind of useful. So that's why 16. And then, yeah, if you're holding shift, it tries to buy everything that it can. Otherwise, it just buys one. And then it updates the button name. You have to do this because it's static. It's not reading this variable every frame. So you just have to put that in. To buy one, we increment workers. And then the score, we subtract the price from it. So that's how you buy it, right? You spend the score. And then worker price, we're increasing it with the inflation. And we're making sure it goes up by at least one every time. But it's going to be this multiplier here. So it's going to always go up more than one over time. And then buy all is just a loop, a while loop. So while there is money to spend on this, then buy one while there's enough. So you can reuse your code like this in here as well as up here. That's kind of the idea with these functions, if you're unfamiliar with that. Okay, that's pretty good for that. After the buttons, yeah, these are going to be similar, right? Just different colors and doing stuff like that. And then now we're in the draw function. That's going to happen every frame. And the first thing we want to do is find out how much time has elapsed between the current frame and the previous frame. Because if I go away from this for any amount of time that multiple frames could go, and I come back, only one frame will have been drawn. And so we want to know how much time that was between those frames. And then we could make this number go up. If you were gone for like, an hour, you could have this, and you come back to it, this thing will still tick up because it will know by the system clock how much time has gone by, and it will calculate how much to go up by. So the way we do that is in time. So we initialize an elapsed time as 0. This is what we're going to use. And then we've got a previous milliseconds of also 0. And then we're getting this little local variable here, milliseconds. We're just saying, give me the millis, which is our milliseconds. It just ticks up really, really fast. And so you grab that from the system clock. And so this starts at 0, but it's going to end up being the previous milliseconds that we just grabbed. And then we're just getting the difference from that to get the difference from the previous to the current. And then this gets used in everything. All right, so next we calculate our rate. That's this number down here. Calculate rate is done with a timer. So we're saying, hey, give me the elapsed time between the frames, right? Increment that. So this timer is going up with the amount of time that's going on. And then we are saying if it's greater than 3 seconds, then remove 3 seconds from it. I might need to do that with, I might need to make this work with like a lot of time if we went away and came back. But for now, this is probably fine. And then because this will only work once. Actually, no, we don't care if it only does it once. That's fine. So we're saying just remove that 3000. It'll do it again next frame, I guess, if it had to. And then And then we're going to calculate the rate. So we're getting the total minus our previous total. What that is the amount of score that we've gained, but without losing any when we purchase. And so we use these two numbers here to give us how much we gained over the amount of time, 3 seconds, right? So this over 3 would be how much we've gained per second in the elapsed time. And then we add it to the previous rate, which is the same, units. And then we divide that by 2, and that gives us the average between the previous rate and the new rate. And so we're getting this running average over time, and that's how this works. And then you just have to make sure your previous total gets updated to the total. Draw background is pretty simple. It's just draw a background color for the sky in case the image doesn't show up. And then we load the image in on top of it. And then it just goes in 0, 0 at the top corner here. And then we turn off the stroke, put in fill for the ground color, this one right here. And we put a rectangle in the space here. The way you can really easily get a matching color like this is if you go, let me go to the colors. So that's our ground color right here. If you put just like 0, 0, 0 in here, or whatever you want, it'll pop a little picker icon there. And you can, it's hard to see sometimes, but there's like a little eyedropper right here. You can literally just grab the pixel that you want. And it gets you the pixel that you need. And it'll match. If I just kind of drew it so it was that color at the bottom. But yeah. Back into our sketch here. For our background, we're done with that. Draw score and rate. So that's how we actually draw this text here. So that's underscore and rate. To draw it, we're just putting some text together, so it's pretty simple. Again, no stroke, just in case there was. I could put a color from our color object in here, but this happens to just be an RGB value. Red, green, and blue for these three, up to 255. So that gives us this light, kind of warm sand color. We're making our text 40 points. That's pretty nice and big for this guy. And then we're centering it, center aligning it. So if we give it a position here, it's going to center on that position. And then we're giving it that center position and making it go 550 down. And then we're putting the score there with that number function. Then we're doing the same thing, but at 20, and we're giving it the rate, and we're giving it this per second thing, and putting it a little bit lower. All right, back to sketch. Scale down onc. We want to do this every frame because we want, as we click the onc, it can get bigger. We want it to go back to its original size. So the way it's doing that is in here. Scale down onc is under onc. Here it is. So we're just saying if the onc is greater than its original size of 96, then if it's greater than its maximum size that we want it to have, then we set it to that maximum size, clamping it. So it can never get bigger than 124 pixels wide. And then if the onc size, and then we set the onc size to 99% of what it was. So it's going down 1% every frame. And we aren't doing the elapsed time for this one because we want a nice smooth animation. We don't really care for it to remember how far through the animation it was if we went away and come back. So that's why we're doing it with frames instead of the elapsed. And then this is just giving it a clamp on the lower end because we're doing this percentage change here. So it could possibly go below 96 there inside of this loop or inside of this if statement. So we just want to make sure it doesn't go below. Cool. And then we do some stuff here to say, hey, is the worker button showing? And similar for the Zebu button and the favor button. So if it is showing, and if we have workers, so this number here, then draw that number there. And then, you can see it's pulsing with the workers. That's just because we've got like these particles with a color associated with them, and as they're dying off, they're fading away, and we're using that fading color for this number. So if I go into worker and calculate, there it is. So some text, so we're getting the text we want to use. We're saying the size, left aligned, and giving it that position there. And then we're drawing a shadow underneath. That's this one. And we're using this worker low light color, I guess, darker color, and drawing the same text. So again, this one just changes its alpha over time and is right on top. Cool. Update worker button is just changing the text from black to white, depending on if you have enough to pay for it. So that's pretty simple. Update button, yeah, right here. So if score is greater than or equal to price, then it's white, otherwise it's black. Pretty simple. Similar with the Zebu. So for favor, we're doing a little bit more here. We're saying if it's showing, if we have favor, this number here, and if it's glowing at all, then calculate favor and draw the onc glow. So we have this kind of minimum value of 0.01 of onc glow, 1%. And then also if we have favor, draw this number here and update the button, just like we're doing with these guys up here. So this part's the interesting part here, right? So let's look at calculate favor. In calculate favor, we have another timer. It goes up with the elapsed. We're saying how much work are we doing? And if we go up to the initializer here, we can see that start with 0 favor, timer starts at 0. We have this cooldown of a second. And this alpha is white, like fully opaque at 255. So when this is like all the way white, that's at 255. So to get the amount of work we're doing, this is going to be used to kind of give our score bonus from the favor clicking. We're saying how much time has passed. So it's a product of the amount of time, how much glow we have, and this is kind of it's close to 300, so 255, 300, close enough. So that's why I do that. And then we say over cooldown, so per second. So this gives you per second stuff, per second score. And then, so that's our work that we define. And then we're saying if you have favor and work is greater than or equal to 1, so if you have enough work, you've done 1 unit of work at least, then like that's basically 1 or more score. Then it's going to be multiplied by favor. So how many you bought here. So if I have 3 here and I'm clicking every second, it's going to give 3. But it's also times the amount of glow that you got and the amount of time that's passed over. Yeah, so yeah. So that's what we do. This is whenever we increase the score, we are also increasing total. And then the time gets reset by getting the remainder after we've taken all the cooldown off, because this takes into account how many times. So if it was somehow 3 seconds had elapsed, this would do like 3 times the amount, and then you want to take off 3 times the amount. So you just get the remainder. And every time we get it, every second, the favor alpha is going to be opaque again. And then we want to say, while the alpha is greater than 100, we're going to start reducing it. So it's going to fade it. And then if the onc glow is greater than 0.1, then we're going to draw the color, right, at 0. Or we're going to set the alpha. So we're going to say that it's going to be this alpha. Otherwise, we're just going to say 0. So we just don't want to, we don't want it to show up after glow is down to a certain level. So that's how all of that works. And then if we have workers, we want to calculate the workers, so similar stuff for them. Calculate workers. Here we go. So we've got a timer for workers. They get a simpler calculation for work. Basically what we're doing here is saying the amount of time that's passed over their 3 seconds. If enough time passes to get one score at least, then we add worker scores and reset the clock for them and add particles and also click the yonk. So it does a little bump every time I get it. So add worker scores, it's down here. So we've got Zebu workers and solo workers, because when you get a Zebu, one worker gives you 5 score every 3 seconds instead of 1. So that's the way it works. We're going to find out how many of them. So we get the minimum between the two. So if you have 1, you're only going to get 1 Zebu worker. And if you have like 1 worker and 12 Zebu, you're only going to get 1 still. Oops. And then solo workers are the remainder. Zebu worker score is, 5 times. And we put in the work, right? So that's the time based variable there. And then we just increment score in total by that. We also do the same with solo workers. They only get 1 instead of 5. Pretty simple stuff. And then we talked about the particles as well, right? So let's look at that real quick. So we have this whole particles file over here. This is actually an object-oriented way to do it. So most of this is just functional, but particles is object-oriented. So in this case, we're saying add worker particles, specifically for workers, right? And actually, this is also Zebu workers, I believe. Yeah. So we got Zebu workers here and solo workers here. So we're looping through all the Zebu workers. We're setting the an object that we're going to send into our particle constructor. And so we're saying we set it up so that you can kind of give it some vector directionality. So in this case, we're saying we want the downward value. So positive is down, negative is up. So it can go anywhere from negative 0.3 up to negative 0.1 up. So 10 to 30% upwards, essentially, randomly. Size is 8 for the Zebu guys. They're a little bit bigger. If I make a few of those, you might be able to see them. They're a little bit bigger. And then the Zebu color. So we're assigning all of those as starting parts for a new particle. And we're putting it into our list of worker particles. Similarly, we do solo ones. They're the same here, but they're smaller, and they get the worker color. This, again, is the same color we're using for the text. That's why it works. And then in the particle stuff, let's look at how our constructor works. Make sure angles, degrees, and then we're passing in an object, so we just want to make sure that object exists so that it doesn't break anything. We're getting an angle and a distance, an x and a y. So anytime we do this or symbol here, it means that like you can pass in this key with a value, and if that's there, then it'll not do this instead, right? So this is kind of like the default if you don't pass in an angle, and this is the default if you don't pass in a distance. X and Y similarly. We have an awk X and an awk Y. That's the position of there. It's default for this. I might change that in the future and just pass it in, but this is fine. Position, so we're creating a vector. We're giving it an x and a y, but it's also getting that distance and the cosine of the angle here for the x, sine of the angle for the y, and that's kind of our polar positioning. And what that does is like you can just give it an x and a y and give it like distances on those two things, but then you end up with kind of a squarish shape, which doesn't seem very natural for particles. So this is a circular shape if you do these things. The cosine of the x angle, or of the angle plus the x, times the distance that you want it to go from the x. And same thing for y, but with sine. Okay, and then we've got an acceleration. So this is the position and acceleration here. So this one's the subtraction of the position from this vector that we give it, which I believe, I'm trying to remember what 460 was. I think that's just the center of the onc. I could probably have put onc x and onc y there. And then we're getting the magnitude as a speed value. Just pulling that out for now. And then the color is equal to whatever color we passed in, or white, looks like. Size, whatever color, or what size we give it, or 1. And then we give it the down or the right, so this is our horizontal and vertical values. That can be random if we don't give it to them. And it's got a lifetime. This kind of dictates when they go away, like how long. So by default, it would be 2 seconds. This is the timer it uses to count up to that for milliseconds. And then you can set the fade to be true or not. And you can set the shrink to like a value of how much it shrinks. So like 5% essentially. And then if we go back to Sketch real quick, draw particles, yeah, so draw worker particles. If we go into Sketch, I know time's almost over here, I'm gonna pause this. So in worker draw particles, it's just doing a loop, and we're doing it in reverse because we could remove the particles here if their timer is greater than or equal to their lifetime. So that's how they die off. That's how you don't end up with like a million particles just bogging down your system over time. Yeah, we just define a particle here as one of them in the list. And then we're just calling update and draw on them. So let's look at those in the particle object class. So we got update here. It's just incrementing the milliseconds, the timer for that based on elapsed time. We're updating our acceleration. This is how it applies the kind of push that you want to give it in a certain direction, either right or down, negative or positive, either of those. And then we're multiplying acceleration by 0.95, so it's slowing down by 5% every frame. And we are adding the acceleration to our position to move forward. And then speed, we're getting it again as the magnitude. I'm not sure if I actually use the speed, but I think at one point I was using the speed to determine when they should die off, but not doing that anymore. We just got a timer. And then draw, we're making sure we're in centered ellipse mode, so draws at the point that is centered on the point that it's at. We're getting the time ratio of like its lifetime, basically how close it is to being dead. And then if we've got fade, then we fade the alpha, the transparency of the color based on that ratio. And if we've got shrink, then the size goes down to 0, but is also based on our shrink value and the time ratio to its demise. That math's a little bit complicated, but I kind of split it up here. But essentially size times the inverse of our shrink value, and then we add size times the ratio. And then those are two things, and we're basically putting that over the inverse of shrink again, and 1. Basically, I'm not going to explain how that works because can't really think of it right off the top to explain that. But it's maybe a bit of trial and error to get that to work, but eventually you get to a point where you think it through and you're like, oh, that's what it does. And then we just fill it with color, draw the circle at that point with that size. Okay. I think that's it for today. So next time we will go on to the rest of this. We'll start looking at the onc. These are pretty basic things. And then really, actually I could probably finish up. So let's just do that real quick. So we've got draw onc. And we're just drawing the onc. We're giving it the right color. We're giving it that glow color. Oh, this is a glow. We just want to draw the onc. There it is. So I'm just defining a quick half the onc size right here. It's because we used that a couple times. Then we're just drawing the image at the position and at this current size. So this position stays the same, the size changes. And oh yeah, so if these right here are dictating when we show the worker buttons and stuff right here, to actually switch it over. So if it was hidden and the score is enough to unhide it, then we show it and set the hide to 0 so we can check it as a variable. And then same thing with these. And lastly, I think that's all we had here. Yeah, is just mouse pressed. So mouse press is a function that happens whenever the button clicks, whenever you click your mouse. So we have a function that says mouse over onc, and that's just looking at the position of the mouse. And it just returns a true or false based on these different conditions. So they have to all be true for the mouse to be over the onc. So it's like the middle third below 400. So we made it nice and big. And then if that's true, then we can click the onc and we click it and pass in the score per click. So this is why I have this kind of passed in like this, is like if I want it to kind of jump every 3 seconds, I don't want it to also already add a click in there. So if we don't pass this in, then it doesn't tick up the score, but it does do the animation. Clicking the onc is just checking if that up score that we just passed in is a number that's usable, and then we increment those by that score. Let me change that real quick. Haven't really got to a point where we add more than one. And then, but that could be like an upgrade. And then onc size goes up, and onc glow goes up. And then here's where we slowly fade the onc glow. Okay, so it's in click onc. It's a little bit of a weird spot, but I guess that's fine. Yeah, okay, I think that's about it. So next we'll maybe add some more features onto this and show how that's working. Let me know what you think, guys, and if you have any suggestions or want to see more of this, comment down below and look out for the next one. All right, thanks, and have a great day. Bye.